Okay, problem number 9. Two identical bumper cars, initial velocities as shown, direct collision. After collision, car A bounces back with a given speed. So I'm going to draw that over here in red. So car A bounces back in the opposite direction, 3 feet per second. Determine the coefficient of restitution between the two bumper cars. Okay, so let's see if I've read through this again. We don't know or not given the velocity of B prime. Let's go ahead and assume it's going to bounce back that direction. They're identical cars. Okay. So, by asking about coefficient restitution, that tells us it's probably not perfectly elastic. It's not perfectly inelastic. So, let's do conservation of momentum. Okay, let's use positive to the right. And these have the same masses, they're identical. Okay, I'm going to go ahead and write them in, then cancel them out. So mass of A, velocity of A, mass of B, velocity of B, mass of A, velocity of B. After the collision, that's A, not sure why I said B, plus the mass of B times the velocity of B after the collision. Okay, so we said they're identical, so mass appears in every one of them, so that drops out. Alright, and we can plug in our numbers. We have 5 to the right. B is minus 7. Okay, afterwards we're given that A is a minus 3. And so we can easily solve for velocity of B after the collision. Alright, looks like 5 plus a minus 7 is a minus 2, and add 3 to that is a positive 1. So VB prime equals 1 foot per second to the right. Alright, and then we have an equation for coefficient restitution, negative, however we want to write it, VA prime minus VB prime over VA minus VB. So just be careful with signs and labels and everything. So it's going to be minus. Okay, VA prime is a minus 3. VB prime, we said, was a positive 1, so it's minus 1 here. Okay. VA was 5, and it's going to be minus a minus 7. So lots of negative signs. Alright, minus 3 minus 1 is 4, but that's negative. And 5 minus a minus 7, so that's 12. Let's see, so this is the minus 4, but that sign makes it a positive 4. This is a positive 12. 4 over 12 is equal to 0.33. Coefficient restitution is unitless. So this is our coefficient restitution equation. Okay, so the numbers worked out really nicely, and as long as we understand the two principles here, this problem wasn't too bad.